सर वो शाहरुख खान की मूवी जैसा हो गया है, कमी कमी एक ही बार आएगा साल में, एकदम 100 करोड़ कमा के सर। Sir, we'll start at 5. Let's Mishra sir again join then.
Sure.
Yes, sir. सर ठंड कैसी है वहाँ ये में संगरूर में?
It is around 5 degree.
अरे बाप रे सर, यहाँ तो ठंड आई और कब चली गई पता भी नहीं चला।
At present it is 14 degree.
Oh.
Ajay, good evening to you all. प्रद्युमन कुमार का तो फोटो दिख रहा है लेकिन नाम तो नहीं दिख रहा है कहीं।
गुड इवनिंग सर।
गुड इवनिंग, क्या हाल है? बहुत ठंडा है क्या अभी आपके वहाँ लोंगोवाल में?
सर अभी प्रेजेंटली सर 14 डिग्री है।
13?
14 सर।
14? अच्छा।
लोएस्ट सर 5 डिग्री जा रहा है अभी।
अरे यहाँ तो खड़गपुर में तो पूरा एकदम से ऑलमोस्ट गर्म हो गया।
सर यहाँ पे भी कब ठंड आई, मैं वही प्रद्युमन सर को बोल रही थी कि कब ठंड आई और कब गई पता भी नहीं चला।
हाँ, अभी फिर दोबारा फिर आएगा, लेकिन एक बैग ऐसा अभी 2 दिन से इवन फैन चलाने की नौबत आ रही है। हाजी जाकिर, हाउ आर यू? गुड इवनिंग। अभी लोग ज्वाइन कर रहे हैं, गुड।
धीरे धीरे करेंगे सर, अभी 5 बजे का टाइम है, तो धीरे धीरे लोग आएंगे।
आपके स्टूडेंट काफी दिख रहे हैं।
हाँ सर, मैं देख रहा हूँ। अच्छे
सर
स्टूडेंट्स।
प्रद्युमन सर का हाईएस्ट अभी तक का है हमारा रिकॉर्ड, 400 स्टूडेंट्स का रजिस्ट्रेशन था। तो
हाँ।
मैंने बोला वही कि सर आपका वो सलमान खान की मूवी के लिए शॉर्ट नोटिस था, लेकिन 100 करोड़ कमा के गए।
गुड, वेरी गुड।
एक्चुअली द नंबर ऑफ रजिस्ट्रेशन में भी हाई है। एक वेबिनार हमने भी कराया था, तो इन दैट केसेस द टोटल रजिस्ट्रेशन वो 650। तो
हाँ
लेकिन
सर।
हाँ, तो उस टाइम में पार्टिसिपेशन वाज, हमारे पास लिमिटेशन थी 250 की। तो 212-13 लोग तक ज्वाइन किए थे उस वाले वेबिनार में।
हम लोग क्या फिर ये लोग फेसबुक और इसमें यूट्यूब में भी दे देते हैं लिंक ना, तो दे
हाँ
मैंने
एग्जैक्टली, यस
बहुत
सर।
कुछ उससे भी ज्वाइन करते हैं।
जी 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 सर।
गुड।
और कई लोग सर जो मैं देखता हूँ कि ज्वाइन करके वो बस ज्वाइन ही करते हैं और कुछ करते नहीं
हाँ,
आगे।
वो तो ठीक है। इसमें भी बहुत
क्योंकि
क्वेरी
मैं,
आती है बहुत लोग के, सर्टिफिकेट सर मिलेगा कि नहीं,
हाँ, मेन
सर्टिफिकेट।
मेन 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 सर वही होता है। जैसे हमने भी बहुत उस वेबिनार में मुझे लगता है कि कम से कम हमने टोटल जो है 2500 के आसपास सर्टिफिकेट डिस्ट्रीब्यूट किए, छह वेबिनार पे।
हम लोग तो खैर इसमें सर्टिफिकेट वी आर नॉट गिविंग बिकॉज इट इज नॉट फॉर द सर्टिफिकेट, रादर इट इज फॉर द नॉलेज। अगर
यस
किसी को
सर,
नॉलेज लेना है आओ ज्वाइन करो।
श्योर श्योर सर।
एग्जैक्टली सर, वही वही ठीक रहता है यार।
हाँ जी, हाँ जाके तो
हाय जाकिर।
यहाँ
जी
ज्ञान बांट रहे हैं हम लोग, सर्टिफिकेट
जी,
नहीं।
एग्जैक्टली सर।
तो पता ही रहता है। तो फिर भी पीपल आर कमिंग, एंड अभी तक तो वी हैव सीन वेरी गुड रिस्पांस एंड पीपल फ्रॉम अक्रॉस द कंट्री तो आ ही रहे हैं, कहीं कहीं देख रहे हैं बाहर से भी, कंट्री के बाहर से भी लोग आ रहे हैं कुछ सेमिनार में कर। And Jackie is one of our, he doesn't miss any. I am very happy. अच्छा भाई, सीखने की ना तो कोई उम्र होती है ना कोई सीमा होती है।
बिल्कुल सर।
एक्चुअली सर वो लास्ट लेक्चर में ना ये इंटरनेट कनेक्शन नहीं था यहाँ पे, बिकॉज ऑफ बीबीसी इलेक्शंस, तो इसकी वजह से वो लास्ट लेक्चर मिस हो गया, अदरवाइज आई वुड हैव बीन प्रेजेंट।
गुड गुड गुड।
अभी तो ये लोग जैसे तुम लोगों को क्या घर घर पे अभी आजकल क्या काम चल रहा है, कुछ काम हो रहा है?
सर वही थोड़ा बहुत जो काम चल रहा है, पीपीटी वगैरह, पेपर वगैरह कम्युनिकेट कर रहे हैं। एक्चुअली एक्सेसिबिलिटी सर का प्रॉब्लम हो जाता है ना सर, लैपटॉप वगैरह भी नहीं रहते। वहाँ क्या हो जाता है, दूसरे का लैपटॉप पे भी थोड़ा दो लैपटॉप पे काम कर लेते हैं, बीच में लैपटॉप खराब हो गया फिर देना पड़ा, तो तब तक के लिए काम रुका हुआ रहता है। कोई थोड़ा इशू हो जाता है।
अभी तो
लैब में सर हम लोग 9:30 बजे से आ रहे थे, तो लैब में पूरा पैक रहते थे, पता था कि उस समय पूरा एकदम लंच तक पूरा कुछ करके नहीं, यहाँ पे थोड़ा बैठ तो पीछे से कोई कुछ बुला ले, फिर ये
मम्मी आ जाएंगे, कभी पापा आ जाएंगे।
हाँ, मैं तो रूम बंद कर देती हूँ, फिर भी पापा जब रहते हैं वो तो लैब अब लगता है कि लैब वाज मच बेटर फॉर वर्किंग एनवायरनमेंट एटलीस्ट, और पहले से हम लोग प्लान भी करके रखते थे कि
अभी तो
आज ये करना है।
2 लोग तो अभी आ रहे हैं, देखो जयंत आ गया है और ये कल आ रही है।
हाँ, नित्य आ रही है सर,
क्या कल आ रही है।
हमें भी बुला ले तो अच्छा है सर। अब हम लोग का भी मतलब हो गया बस एक तो मैं तो सिर्फ ठंड का कुछ कपड़ा भी लेके नहीं आई थी, मुझे लगा था अगस्त में दोबारा बुलाएंगे। एक वो घर पे ही बस एक स्वेटर था, हर जगह वही स्वेटर पहन के जाती हूँ क्योंकि हम लोग जून में आए।
अब वैक्सीन इत्यादि तो आ रही है, तो हो सकता है उसके बाद सिचुएशन
हमें जब पूरा कोविड लॉकडाउन था तब तो हम लोग केजीपी में ही थे, जाते भी थे बीच बीच में थोड़ा देखने के लिए, और अब जब लॉकडाउन हो गया तो फिर हमें पेपर के रिविजन्स वगैरह आ रहे, वही रिविजन्स वगैरह आंसर कर रहे हैं और क्या। अभी थोड़े बहुत रिव्यूअर के कमेंट्स आ रहे हैं तो कुछ करके तो भेजते हैं।
गुड।
देखिए सर उतना एफर्टफुल काम नहीं होता है जितना हम लोग लैब में करते हैं, मतलब ज्यादा।
लैब में तो देखो प्लान्ड वर्क होता है ना, घर पे तो मर्जी है तो आज 9 बजे उठ रहे।
माहौल होता है, लोग साथ में रहते हैं,
बिल्कुल
एक दूसरे को देख के काम करते हैं कि वो कर रहा है तो हम भी कर ले, और ये तो
बिल्कुल
बहुत से।
और सर वो एक सीरियल रहता है ना कि कोई इक्विपमेंट वो आज काम करेगा तो वो पहले से
हाँ,
बोलता है मैं 2 दिन पहले काम करूंगा, तो हम लोग उस 2 दिन में अपना काम खत्म करने की कोशिश करते हैं कि रात में जाके भले या थोड़ा लेट से जाके क्या कल उसको वो इक्विपमेंट देना है, क्योंकि उसने भी सैंपल बना के रखना होता है अपना केमिकल का,
बिल्कुल।
वो एक ये रहता है।
पांडे जी, हृदय पांडे जी।
पांडे जी भी रेगुलर ज्वाइन करते हैं, पांडे जी और शुक्ला जी। पांडे जी आ गए क्या?
हाँ हाँ हाँ,
हाँ नमस्ते सर।
नमस्कार, क्या हाल है?
पांडे जी तो अभी बहुत बढ़िया प्रोग्राम करा रहे हैं अपना राबी में, RABI में।
हाँ 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 हाँ।
इन लोगों का भी काफी एक्टिव डिपार्टमेंट है, जहाँ कुछ ना कुछ चलता रहता है। गुड।
एक्चुअली सर नंबर ऑफ फैकल्टी बहुत है सर वहाँ पे, और ये लोग एक्टिव भी बहुत है। टाइम जो है कुछ ना कुछ नया नया चीज कराते रहते हैं।
सर फैकल्टी तो हमारे धीरे धीरे कम हो रहे सर, अभी है नहीं उतने, पहले शुरू में जितने थे कम हो गए।
हाँ हाँ हाँ, अभी एक आपके वो रिटायर हो गए ना एक तो।
हाँ जोशी साहब रिटायर हो गए, उसके बाद में
हाँ,
कई सारे लोग चले गए ना। अब नेमा सर थे, ये क्या नाम, चक्रवर्ती था,
सुवीर।
देवरिया मैडम थी, पराग सुतार, नम्रता, चले गए।
पराग सुतार नम्रता तो बहुत पहले चले गए, तो आज
हाँ
थोड़ा
तो वही सब चले गए, तो जितने लोग थे कोई कोई अभी तो यहीं के लोकल लोग सब ज्यादातर।
शुक्ला जी अभी नहीं ज्वाइन किए, क्या बात है? शुक्ला जी भी रेगुलर रहते हैं।
सर आई थिंक कश्मीर में तो शायद स्नोफॉल की वजह से सब कुछ कट है शायद।
नहीं नहीं, देखो जाकिर भी कश्मीर से ही है, श्रीनगर से ही है।
और है श्रीनगर से लोग हैं कुछ?
नहीं, श्रीनगर से सर 2-3 स्टूडेंट्स हैं अभी, मैं
हाँ
देख
वही
रहा
तो
हूँ।
नाम मैं देख रहा हूँ। यस यस।
हाँ
आते होंगे सर, शुक्ला सर आते होंगे अभी।
एक तजामुल भी है सर, देखिए तजामुल का सर आपने PhD का वाइवा आपने ही लिया था।
अच्छा हाँ हाँ।
तजामुल
गुड इवनिंग सर।
हाँ, कैसे हो?
सर ठीक, आप ठीक है सर?
हाँ हाँ हाँ, बढ़िया बढ़िया बढ़िया। मैं वही कह रहा था कि मिश्रा सर को कि तजामुल का सर आपने जो है
जी जी, ये मेरे ये थे PhD के टाइम पे एक्सपर्ट।
अभी क्या कर रहा है तजामुल?
सर हमारा बिजनेस है एक्चुअली, डिपार्टमेंटल स्टोर है फिलहाल।
कहाँ, श्रीनगर में?
जी सर, नहीं पुलवामा में, जहाँ मैं रहता हूँ सर।
अच्छा पुलवामा में, वेरी गुड।
जी सर।
नाइस। तो जैसे 5 बज गया, आई थिंक
हाँ सर वी विल स्टार्ट।
आई विल स्टार्ट, पीपल विल बी ज्वाइनिंग एनीवे। क्यों प्रदुमन कुमार?
यस सर, यस सर, यस।
Okay. Good evening, everyone. A warm New Year wishes to all. Due to some, we will be sorry. We'll be giving our sorry and saddening information that due to some unavoidable circumstances, we shifted the webinar, which was on 9th, and on a very short notice, Dr. Pradyuman Kumar joined us. And there is a very great participation from the students, and FCTL is very thankful for that. Before that, I want to introduce Pradyuman sir, as although I have heard he is one of the most senior academician from our lab, and he has achieved a lot in his career, but somehow I always feel he has a very good connect with the younger generation. I have seen him when I am in lab, and before that also with my seniors also. He's really friendly. You will not. He's someone who, for whom you can go for a suggestion, and he's someone who can give you a very research-oriented answer, as well as he's very friendly on his ways. And we all juniors, every year a batch come. There are some few students who always hear about. One of them is Pradyuman sir, and I would like to introduce Mishra. I would like to invite Mishra sir to tell a few words about Pradyuman sir. Then I will take the webinar, because this webinar is all about reminiscing the old memories and going back to a nostalgia for a few moments of our life. Sir.
Thank you, Jasri. That it's my proud privilege to have one of a very, very senior member of our family today. And in fact, as you have very rightly told, that Dr. Pradyuman Kumar is one among the very, very sincere members of the FCTL Food Chemistry and Technology Laboratory. And I have not seen any occasion where his presence is not there in any FCTL related programs, etc. In our group also, he is very active. And in addition to that, he has always been very cordial, and he always comes forward with his help and ideas to everybody. And when he was doing PhD, in fact, I told earlier about Sinija, and the other were Pradyuman Kumar. They were the people who produced the largest number of PhD research paper in peer-reviewed journal while doing their experiment work. Am I right, Professor Kumar?
Yes. Yes, sir. Yes.
And I think it was again in his case
with all your cooperation, support, and guidance, sir.
I think about 9 or more than that papers were published by Dr. Pradyuman Kumar, and that too in the period of 3 years.
Yes. Yes.
He also had written all his thesis, and he was waiting 3 years to be completed to submit the thesis.
Yes.
Okay, and the third thing, this all he did while he was doing PhD, staying with his family.
Yes.
With his small kid. And I think he has also got some reward, a PhD reward during that period. There was addition in his family.
Yes.
Am I right?
Yes, sir. Yes.
So
Yes, sir.
in all these engagement, and still he produced maximum number of papers, and his thesis was highly appreciated by external examiners, etc. He worked on mango soya fortified yogurt powder, and produced some of the largest papers with the largest citation also in our group. His papers are few amongst the largest citation having papers. So
yes,
this I think that is although by now we have produced from the laboratory about more than 45 PhD students, including those 50, including those which are already registered and from the produce. He is a very, very specialized and persons and knowledgeable person. So in fact, I or anyone would love to have students and colleagues like Professor Pradyuman Kumar. I think all the other people, his students, SLIET students are also there, and I am happy that he has made a similar, he has made a place and recognition for himself in the field of food science and technology. And he is imparting the similar kind of training to his colleagues, and which I have quite a few intimate interactions. Some of his students, and one good example is here, Zakir.
Yes, sir.
But
Yeah.
Zakir, I didn't know earlier Zakir. And it
Yes,
was
sir.
he introduced me to Zakir, or Zakir to me. And that shows that what type of training, the way he is there, and he is always, means it feels, we feel that yes, he is also among, of course, he is also a family member. It is the same family tree. So that what type of training has been inculcated and by such etc. I think this is things. Let us go over to Jayashree for the seminar.
Thank you, sir, for your kind words. Because without your support, I could not be able to complete the PhD in time and to publish so many papers. And I am very blessed that you had provided each and every platform for the benefit and for the support to me. Thank you very much, sir. Thank you for your kind words.
Thank you. We'll hear now you.
Thank you so much, sir, for introducing Pradyuman sir on a different note. We all of us must be knowing him as a professor of food engineering and technology, SLIET. So today we are really proud and happy to introduce our speaker, Dr. Pradyuman Kumar, on this FCTL webinar series. Today he will be delivering on extraction of bioactive compounds using supercritical fluid extraction, SCFE technology. And before going to his lecture, I want to introduce him as an academician who has always been very active, almost 200 papers in his list, numerous awards of FST Young Scientist, to many best paper awards. He has completed his PhD from IIT Kharagpur and his MTech from GP Pant, MSc from GP Pant and BSc from BHU Varanasi. And currently he is working on the extraction of bioactive compounds with various other topics. So I'll request Professor Pradyuman to present his presentation, and thank you so much, sir, for joining us and enlightening us. Sir, you can present now.
Okay. Thank you, Jayashree. Thank you. Thank you for introduction to the audience.
Suggestion. Any questions? So we will take all the questions in the chat box. So anyone, please right now keep your video and audio on mute. You can write your question in the chat box. At the end of the this lecture, we will take questions and we will allow the audience also to ask questions directly. In the meantime, you can write your questions related to a topic in the chat box. We will take it accordingly. Thank you so much.
Okay, thank you, Jayashree. So, is it audible now?
Yes, it's audible. Just yes. It's
okay, thank you. So, thank you, Jayashree, and I'm very thankful to Professor N Mishra, sir. He has guided a lot during my PhD program, and without his support and guidance, it would be very difficult for me to complete my PhD and to develop myself, to develop my academic career. And I'm getting some emotional, whatever sir has told me in front of all my students as well present in this webinar. So thank you very much, sir. Today's topic is the extraction of the bioactive compound using supercritical fluid extraction techniques. So before discussing the topic, I would like to discuss in one only slide about the SLIET. So SLIET is a Sant Longowal Institute of Engineering and Technology. It is established by Government of India, Ministry of Education, and it is one of the centrally funded technical institute. This SLIET is having a very unique program. The unique program is we are having integrated certificate and diploma And on the basis of that matriculation, we are taking admission to this ICD program. It is 3-year program. And then we are admitting after 10+2 to the BTech program through the JEE mains. And from the ICD, those students who are also promoted to BTech second year admission. Then MTech, then we are having MSc and PhD. And this campus is around 450 acres of the lush green campus. It's fully equipped lab, and we are having the well-qualified faculty members. We are having the TCube 2 and TCube 3 programs also. We are also having the AICT QIP Center, particularly for the PhDs, those who are interested to pursue the PhD under the QIP. So we are also having this QIP Center. And this is accredited by the NBA and the NAC. And for the hostel facility, we are having 10 boys hostel and 4 girls hostel, along with the basic amenities, basic facilities, that is the marketing complex, swimming pool, student activity center, and so on. So why we talk about the supercritical fluid extraction? There are bioactive compounds, and these bioactive compounds are normally extracted using the organic solvents. But if we wanted to reduce the carbon footprint, because we had seen one has to reduce the carbon footprint because it is harmful for the our atmosphere, our nature. So therefore, the organic solvent uses has to be minimized, right? There is one other disadvantage if we are using these organic solvents. So there are some residual solvents may be present in the bioactive compound. And these residual solvents, they are not good for the human health. Right? So the bioactive compound, which is extracted using the organic solvents and used in food processing, is concerned with the public health, because the public are demanding the ultra pure and high value product. Ultra pure means the purity of the bioactive compound should be very high, and it should be very high added value product. Environmental issue is concerned because by the environmental issue, because the organic solvent is used. So during the extraction, some of the organic solvents in form of the gases, it may be leaked into the atmosphere, which causes the environmental issues. And the safety issue is linked with the, since there is a residual solvent present in this bioactive compound, so it is concerned with the safety issues. There are various methods of the extraction of bioactive compound. If we see the method, maceration, percolation, succinate extraction, pressurized liquid extraction, supercritical. So there are a number of the, you may say, the conventional as well as the novel extraction techniques. So these are the different type of the solvents which are used, right? And it is that condition, extraction condition, that at what temperature, under what pressure, and for how much long, whether it is a time taken is short or long. So depending on that, such kind of the extraction techniques could be used. If we talk about the volume of the organic solvents consumed, so organic solvents is consumed in case of the conventional techniques is little higher. But if we compare this supercritical fluid extraction, in this case, a very small amount of the solvents are utilized. But similarly, if we talk about the polarity of the natural products to be extracted, we can see it is some of them are depending on the type of the extracting solvents used. And in some of the cases, the polar compound could be extracted. In some of the cases, non-polar compound could also be extracted. But in case of the supercritical fluid extraction, mainly the non-polar to moderate polar compounds could be extracted. It means the supercritical fluid extraction can be used for extracting the non-polar to as well as the polar compounds. So these are the extraction techniques. These are the classical, right? In which we may use the different kind of the solvents, maybe the methanol, ethanol, water, acid, alkali, etc. And technique. So in the novel extraction technique, either we may use some enzymes. Nowadays, the ultrasound assisted extraction is taking place. pressurized liquid, supercritical, high pressure, pulse electric field, microwave assisted extraction. So nowadays there is a combination of the classical as well as the novel extraction techniques are used. So in these cases, either we may use the solvent extraction plus the novel extraction techniques, or we may use a combination of novel extraction techniques or novel extraction techniques, right? So any plus any. So in these cases, we can combine the enzyme assisted extraction as well as the ultrasound assisted extraction, or the ultrasound assisted extraction plus microwave assisted extraction. The purpose is that we have to extract the maximum amount of the bioactive compound by means of using a combination of the classical as well as the novel extraction techniques, or a combination of the novel extraction techniques. So these techniques, why we are considering the combination, why we are considering the novel extraction techniques, because it is considered as a clean and green technologies. Now we talk about the alternative of the organic solvents of the related with the supercritical fluids. So these supercritical fluids are normally working at a condition of above the critical temperature and above the critical pressure, right? So under these conditions, there is no distinct phases existing, means the liquid and gas phases do not exist. There is some mixture is available, you may say. So properties that are intermediate between the liquid and gases is available and at above TC and above PC. So at this stage, it is effused through the solids like a gas, right? So it is effusing like a gas, but it is dissolving the bioactive compound as a liquid, right? So one can say that at the close to the critical point, if there is a small variation in the pressure or there is a small variation in the temperature, it results into the large changes in the density, because when we are deviating from the critical pressure or the critical temperature, the density will change. The carbon dioxide and the water, these two are most used supercritical fluids for the extraction of the bioactive compounds. Before going to the extraction techniques, one has to know what are the properties of the different solvents. There are a number of the solvents is shown here. One is the carbon dioxide, which is mostly used in the supercritical fluid extraction. Along with that, the methane, ethane, or these are the different compounds. If we see the critical temperature, the temperature is around, you may say it is 31 degrees centigrade or 304 degree Kelvin. The operating, you may say the critical pressure is 7.38 megapascals, right? And at this stage, the critical density is 0.469, right? But if we see the others, if we see the ethane is having almost similar to the critical temperature, but here the atmospheric, its critical pressure is less than that, right? But this ethane is not normally used for the extraction of the compounds. Now one has to compare the physical properties of the supercritical carbon dioxide at 20 megapascal and 55 degrees centigrade with some selected liquid solvents at 25 degrees centigrade. So this table is basically showing that how the density of this carbon dioxide is compared with some common solvents, right? So here the density is 0.75 and the N-hexane is having a density of 0.66. The methylene chloride is having a higher density, methanol is also relatively high. But if we see the kinematic viscosity is very less of this supercritical carbon dioxide in comparison with the hexane or the methylene chloride or the methanol. Similarly, if you see the value of the diffusivity, the diffusivity value is highest among all these four solvents, right? So the carbon dioxide, supercritical SCF carbon dioxide is having the higher diffusivity. Similarly, we are comparing the physical properties of gas, liquid, and the supercritical fluids. So if we see, this is the gas of the carbon dioxide, it is SCF, and this is the liquid one. So density of the gases is quite natural, it is very low, but under the SCF conditions, it is around 200 to 500 kg per meter cube. The dynamic viscosity is also less than the liquid, or you may say it is the properties of this SCF, or the values of the properties is in between the gas and liquid, which shows that it's good for the extraction of the compound. If we see the phase diagram, it is simply, you may say, you might be, some of the students are there because mostly the students are there. So they are knowing the triple phase of the water. Similarly, here also, it is at some sort of a triple phase. So it is a vapor phase, it is a liquid phase, and it is a solid phase, right? And this is the triple point. But our interest is not on the triple point, but our interest is on this supercritical region, right? So here, when the critical temperature, and this is the critical pressure, right? So the pressure is increases, then the supercritical fluid comes, or when the temperature is in critical fluid, stage comes in these cases. This diagram is showing that how we are using the supercritical fluid extraction. So basically, this is the one of extractor. In this extractor, we are loading the sample, right? And the carbon dioxide, here it is in a gaseous form. With the help of the condenser, it is converted into the liquefied form. And with the help of the pump and with the help of the heater, we can manipulate the flow rate, and we can manipulate the temperature and the pressure inside this extractor. So when the extraction is taking place, it is in the supercritical fluid region, and remaining, they are moving to this gaseous phase, and here it is moving into the liquid phase. So this diagram is showing that how the extraction is taking place under the supercritical fluid phases. This slide is showing the properties of the SCF. This is a supercritical fluid which exhibits the physicochemical properties intermediate between the liquid and the gases, right? And the supercritical fluid have the low viscosity of a gas and high density of a liquid. So that is desired because the low viscosity is always desired for the penetration purposes, right? The supercritical fluid have no surface tension, because the surface tension is also very important for the movement of the bioactive compound from the interior of the raw material to the solvents. The solvent strength, the density of the fluids are closer to that of the organic liquid, but the solubility of the solids is 3 to 10 times is higher. The phase we have here is also taking place in these cases, because we know under the supercritical fluid, it is some sort of a mix of the gas and liquid. Why we always talk about the SCF CO2? Reason why we were talking, it is having the advantageous attributes over the other solvents. The first is the solvating power. The solvating power of this SCF CO2 is similar to the organic liquid solvents, and it is having the higher diffusivity values, lower surface tension, and the viscosity. The separation can be simply affected by simply changing the operating pressure and the temperature to all the solvating power of the solvent. As we know, the solvent is having the different solvating power, right, to the particular type of the bioactive compound. So if we are playing with or if we are managing the operating pressure or the temperature, accordingly, the solvating power of the solvent to a particular bioactive compound can be managed. This solvating power of this solvent could also be enhanced by using some co-solvents. So the co-solvent, normally we are using here the ethanol. So this ethanol is simply going to augment the selective, and the separation power is also improved, particularly to the polar components, because the most of you may say the bioactive compound, they either may be the non-polar or the polar compounds. So if we are using the ethanol as a co-solvent, then they are going to enhance the separation of the polar components. This carbon dioxide could also be an alternative for the industrial solvents. Reason why it is alternative to the organic solvents, because the governmental scrutiny and new regulations. So this due to the government restrictions and the regulations, new regulations, it is restricting the use of the common industrial solvents, right? Particularly the chlorinated hydrocarbons. So therefore, one has to look for the alternative solvents, and the alternative solvents could be the SCFCO2. This is non-toxic in nature. It is environmentally friendly because it is not going to affect the ozone layer, and given that it leaves no traces of solvent residues in food. So this is again very important, because when we there is some residual may be present in the extracted bioactive compound. But when we are using this SCFCO2 residue in the food, at the same time, there is a sharp increase in the energy cost. Why here we are talking about the energy cost? Because if we talk about the organic solvents, its boiling point is maybe ranging from the 60 degrees centigrade to around 85 degrees centigrade, right? So if extract the compound, so at least one has to increase the temperature to 60 degrees centigrade, right? So it means it's, at a lab scale, you may be having a sample of 1 kg or so. But on a commercial scale, we may have a 10,000 kg or 1 ton of the samples, and 1 ton of the sample has to be extracted on a day, right? So one has to increase the temperature to 60 degrees centigrade. So you just see how much energy is involved. That energy cost could be here reduced in this case of the by using this SCFCO2, because this extraction could be carried out lower temperature, right? This is cheap, safe to use, recyclable, and has minimum disposal cost, right? So cheap, why we are talking about it is cheap? Because it could be generated from the atmosphere itself, right? It could be recyclable, means one can recover from the extraction, and after that, watermelon could also be one of the sources for this lycopene. Similarly, the vitamin extraction using the SCFE. So these are the different botanical materials, right, from which the vitamin E or the tocopherol or the tocotrienol could be extracted, right? So wheat germ is again one of the important component from which we can isolate the vitamin E, right, or the tocopherols, right? So similarly, normally we are talking about the waste utilization. So in the waste utilization, the Vitis vinifera, grape seeds, right? So during the wine manufacturing, a lot of seeds are generated, right? And normally what we are doing, these seeds are simply wasted, but there is a techniques that one has to isolate the antioxidant, that is the tocopherol, from these grape seeds, right? Similarly, the grape seed from the other varieties, yeah, we can say that the tocopherol content is very high, 153 to 569 microgram per gram of the oil. And here the tocotrienol is 388 to 547 microgram per gram of the oil. So by use of the techniques, we can produce a number of the bioactive compound from the raw material, from the byproduct, or from the waste of the fruits and the vegetables. Similarly, the fractionation of the flair and fragrances. For the extraction of the flair from the basmati rice and the fragrances from the flour, we know the fragrances are very sensitive, temperature sensitive. So we have to isolate, we have to extract relatively at a lower temperature, right? So these are some of the example. These are the different flowers: jasmine, rose, bitter orange flower, from which these kind of the different flavor compounds could be isolated, which could be used in a different industry, either in the perfumery industry. Similarly, the flavor and fragrances from these plant species, right? The raw material, maybe the onion or the peanuts or the rapeseed cake, and these are the different compounds which can be extracted. Here, the one important is the humulus lipulus, that is the hops, which is used in the beer industry, right? So these two compounds, humulans and lipulans, these two compounds, the basic test providing a compound in case of the beer manufacturing. Similarly, the cholesterol-free products can be produced. As we know, the cholesterol is one of the unavoidable substances. I know Professor Mishra, one student worked on a cholesterol removal from some of the dairy products. So this is also one of the method, SCFE, for the removal of the cholesterol from either the fish muscle or from the beef or the pork. Similarly, the SCCO2 could be used for the extraction of the oil, right? So these are the different seeds: peach seed, apricot seeds, right? Or the different oil seeds, maybe the sunflower, soybean, or the rape seeds. So from all these seeds, the seed oils could be easily extracted, because whenever we are using the solvent extraction techniques, along with the oil, the waxes and other phospholipids are also extracted. And in that cases, the refining process is required. A lot of refining process is required. But when we are using this supercritical fluid extraction, least refining is required. Refining is also required, but the degree of the refining is lesser. Similarly, the separation of the spices and the essential oils. There are many spices which are containing the pungent oleoresins and the essential oils that could be easily extracted from the spices by use of the SCFE. Similarly, the decaffeination of the coffee and tea. As we know, the caffeine, that is one of the mood booster, one can say, or the mood changing compound, one can say. And that is the highest compound is present in the tea. So decaffeination of the coffee and tea could also be there by using this supercritical fluid extraction. Earlier, the decaffeination was done with the one of the organic solvent, methylene chloride, right? So the use of this methylene chloride, slowly it was banned. Reason, this methylene chloride is going to produce some carcinogenic compound. So that's why that was what the use of this methylene chloride was banned. But one has to look for the alternative, and the alternative was to use supercritical fluid extraction for the decaffeination of the coffee, because these caffeine are nowadays used in your soft drink industries. Similarly, the fish oil concentration, the fish oil, which is a very good source of the omega-3 and the omega-6 fatty acids. But in case of the fish oil, the concentration of this PUFA is lesser. So the concentration of this PUFA could be increased by use of the supercritical fractionation techniques. Now, the advantage of this SCFE over the conventional extraction techniques, here just I have taken one or two examples. Walnut oil, if it is extracted, it is containing a very high amount of the tocopherol. Its amount is 405. But when it is extracted by using the conventional techniques, that is hexane, it is hardly having 303. Means it is almost increased by 1.5 times, but just by use of the supercritical fluid techniques. Similarly, the patchouli essential oils, the yield is 5% at 14 megapascal and 40 degrees centigrade, and which is hardly 1.5% by the steam distillation techniques. So such type of the data shows that by use of the SCFE over the conventional techniques, the yield of the bioactive compound or yield of the product could be enhanced. Now, the cost estimation is very important because everyone is talking about that these are the novel techniques, but the cost effective, it should be cost effective. So here the cost estimation, there is a 2-3 kind of the cost is involved. One is the capital cost. So capital cost in this case is the investment required to transform the project into the operational one, operational production unit. So that is the, you may say, the capital cost. Land where the factory is constructed, the terrain preparation, construction of building, right? Then installation of the equipments, first load of the raw material. The choice of the industrial unit is very important, right? Means where we have to establish the industry depending on whether the cost and availability of the raw material. If the raw material is cheaper in that particular area, normally we may have the industry, right? Logistics. Logistic means the transport as well as the, you may say the electricity, you may say the everything that is required to run the industry. That is the raw material, carbon dioxide, co-solvents, etc. And then logistics to send the products to the consumers, then the presence and cost of the trained and untrained workers. Because to run an industry, trained and untrained workers are required, and the cost to purchase the land. There are many SCFE suppliers, the manufacturers. One is the UHD in Germany, Natex in Austria, Thar Technology in the United States, Separex in France. Waters is one of the important. They had supplied the many equipments in India. Extractor volume is from few liters, because on a laboratory scales, the extractor volume may be lowest as 0.25 liter, right? And on an industrial scale to a 17 meter cube. So depending on the requirement, the SCFE equipments could be procured. In case of this cost estimation, there is a different cost is involved, direct manufacturing cost. That is the raw material, the utilities and operating labor, solvent, co-solvent, waste treatment, maintenance of repair, operation supplies, laboratory analysis, patent, royalties. So all these are coming under the direct manufacturing cost. The fixed manufacturing cost means the depreciation of the building, depreciation of the other equipments as well. So now the building depreciation is taken as a 25-year, but for the equipments 10 to 15 years. Then it also includes the taxes, insurance, plant expenses, so all these. And then there is a general manufacturing expenses. That is the overhead of plants for the administrative cost, sale expenses, research and development. So there is a simplified model that can be used in estimation of the manufacturing cost by these 5 major fractions. One is the fixed capital investment, one is the operational labor, one is the waste treatment, utility and raw material. So the maintenance and repair as a function of the fixed capital. So this is the direct manufacturing cost. This direct manufacturing cost is equals to CRM, that is the cost of the raw material, CWT, that is the cost involved for the waste treatment, CUT, that is the for utilities, and COL, that is the operational cost, 1.33, and this is the COM, right? This COM is calculated by using this equation, right? So here the point, this is the equation generated by those who are involved in this cost estimation. So by using this, the direct manufacturing cost can easily be calculated. Now comes to the challenges and the future perspectives. The lower extraction yield of the non-polar carotenoids not appropriate for the samples with greater water content, right? As earlier we discussed that the moisture content should be in a range of 5 to 10%, right? The high cost of the equipment, the initial cost of the equipment is very high. On a lab model, if we are going to purchase this SCFE for half-liter extractor, it is costing around 40 to 50 lakh rupees, right? But the operational cost is lesser, right? As the continuous mode running with recycling of solvent. There is a greater market demand for the bioactive compound, and it is sold at a premium price, right? Normally, whenever we are sick, when we are going to the doctors, nowadays the doctor जो है आजकल एक मेडिसिन लिख देता है साथ में कि विटामिन की कैप्सूल होगी, और विटामिन की कैप्सूल के अंदर जो है बेसिकली उसके साथ साथ लाइकोपिन एक्सट्रैक्ट या जिंको बिलोवा एक्सट्रैक्ट उसमें डला होता है. And one capsule is costing around 20 rupees, and hardly it is having 250 to 500 milligram of the lycopene, right? So there is a great market demand of this bioactive compound. The integration of the technologies accomplish the maximum recovery with greater selectivity of the bioactive compounds, right? Explored for extraction of the bioactive compounds from the microalgae. So nowadays the microalgae are also used as a raw material, and from which the desired bioactive compound could be extracted. Greater selectivity by choosing the most appropriate solvent, co-solvent, on the basis of their interaction with the bioactive compound. So the selectivity could be enhanced by selecting the proper solvents as well as the co-solvents. So now concluding, supercritical fluid extraction has not yet reached the black box stage. SFE is not a fully mature technology. Knowledge of the chemical properties of both analyte and the matrix is important, right? So this is very important. In addition, one must ensure that the mechanism of the SFE is optimized, means the operating parameters, your operating temperature, your operating pressure. So SFE needs to be more fully developed in 5 areas. And one is the rugged extraction method, ease of use, automation, cost effectiveness, and the ability to interface with existing lab instrumentation and computer systems. So with these words, thank you very much. Taken a lot of time.
Good. Okay, Jasri.
Thank you, sir.
Most welcome.
Thank you. So such a like insightful presentation. Like lots of things we came to know on this presentation. But let me quickly first go to this question answer session, and then we will head towards the end. So I'll just request the audience if they have any questions. Then Pradyuman will be, I think, very happy to answer because he has an immense expertise in this field. Anyone can please, we can ask that question.
Anyone is having the related queries, you may ask. I'll try to give the answer. Okay. Yes, okay. Okay, you know that the solubility is linked here, right? So when the solubility is higher, it could be present in the solution, right? So when we are playing with its solubility, then it is precipitated in that particular manner. So here we are using this carbon dioxide. So under the reduced pressure, when it is sprayed, it is precipitated. It's precipitating on the wall on some surfaces. So this is techniques either through the RESS. Yes, yes.
Thank you, sir. Pradyuman sir, I have also have a question. Is anyone?
Sure.
Sir, you told about all that machinery and how to like implement an industry. Like how much earlier when we used to read in BTech, and we have a small lab scale SCFE in our lab also, but it is always regarded as one of the most expensive technologies to be employed in commercial. Again. So as you have an expertise, what is your aspect of like how much is it like employing SCFE for extraction rather than other treatments? How much cost effective or how much it should be more implemented for industry? Like what is your perspective in that sense? Because I have never seen someone giving the whole commercial aspect of SCFE in any of the, like we have never studied regarding that.
Okay. Actually, when we wanted to have a ultra pure product, active compound, right? So we have to use these technologies. Quite natural, we know whenever our product or our bioactive compound is pure, the cost will be higher. You may say the public, those who are interested, the pure product, they are ready to pay. If you talk about the cost of the production, quite natural, the initial capital cost or the establishment of this SCFE equipment is very high. If I say simply, as you said that this particular equipment is also available at KGP, at the time of the purchase, the cost of the equipment may be 40 to 50 lakh rupees, right? And the extractor size is hardly maybe 0.5 to 1 liter. Commercial scale, they may be having a bigger extractor size, right? So quite natural, the initial cost will be higher, but since the running cost is lesser, that's why it is important that one has to use this SCFE techniques.
Okay, thank you, sir. Thank you.
There is some from Rajardhan Sarma.
Sir, you can ask the question directly. We are open to it. Although you have mentioned it, it's Rajvardhan Sharma.
Rajvardhan Sharma, yeah.
Is he here?
Okay, sir, I'll ask.
Sharma ji?
Mr. Sharma.
Rajvardhan ji? Yes, sir. His question is,